Welcome to AI Realized. We're focused on many things at Google Cloud, but we're particularly focused on helping customers with security and AI. Why? Well, security is company's biggest threat, and AI is every company's biggest opportunity. It is just such an exciting area. I'm out visiting customers all the time. We go through whatever is relevant to the customer, and always my favorite part of the conversation is when we start brainstorming how they can really transform their business, taking advantage of AI. In fact, AI is how I kind of got into tech, because I was studying naval architecture at MIT, and the apartment upstairs from me happened to be full of AI PhD students. And this was back in the 70s, actually, 1977. And back then, it wasn't all that useful, but it was certainly super interesting. And then when I went back to school to study AI at Berkeley, it still wasn't all that useful. All the people that went into AI became professors, but now they're all working in industry. But anyhow, so fast forward to today, where AI has become tremendously useful, and Google Cloud is really doubled down on making it powerfully useful and super easy to use. So you can do things like just take an API for image recognition and pop it into your program, and suddenly you have this magical search of an image, extraction of images. But to really exploit AI, it can really require a rethinking of how you do all your processes in a company. You know, when the internet happened and retailers thought, well, I better become digital, and they put up a website. And what we all know now is what they had to do was rethink their whole companies. But people argue that the benefits of this digital age haven't even fully materialized yet. This economist, Robert Solow, has this great quote: "You can see the computer age everywhere, but in the productivity statistics." The big internet companies have definitely seen the gains, but it's just starting to spread out to every industry. Look back at the industrial age. These things take time. When electric motors came out to replace the steam engine, it took tens of, sometimes 20 years for people to redesign their factories. And similarly, AI is going to take a while too. When we talk about AI, we typically today mean neural networks. It's turned out to be kind of the best solution for a huge variety of problems, things from vision, speech recognition, language understanding, even predictive maintenance. It's certainly been heavily used at Google. You know, we've had these computers around for a long time. They're pretty fast ones even, but we've just been limited in what we can create. We've been constrained by the ability of the computer scientists to devise algorithms to solve the problems. And oftentimes we find that these algorithms just can't do a good enough job that they're actually ever going to be used by someone. You can't solve things with an algorithm like image recognition or natural language processing. So rather than using an algorithm, we've discovered that we can use a neural network, and we can train it to do the things we were trying to hand code these algorithms to do. There's a fun heuristic out there that anything that a human can do in a second or less can probably be done better by a computer, an AI. So neural networks have been around for a long time, since the 80s and 90s, but we needed a lot more data, a lot more big compute in order to start realizing the breakthroughs we've been seeing. And so in the last 10 to 20 years, we started to have access to a lot of data and huge computer clusters. You know, the internet, mobile, the cloud, you know, there's over 8 billion connected devices out there, and the data is just streaming in. And in terms of compute, I mean, like at Google, we build these TPU compute pods Any one of them ranks as one of the top 20 supercomputers in the world, and we're building about one of them a week right now. And in fact, if the rest of the world started using AI the way Google's using it, there is no way anybody could meet the demand for a while. So the cloud has really ushered in this new era of AI. It's really a revolution in how we go after these problems that the algorithms couldn't solve. If you think about it, the industrial age kind of gave us this mechanical leverage, and now AI is giving us mental leverage, brain leverage. What this chart shows you is the effect of having more data and having the compute to handle bigger models, how that affects the accuracy of a machine learning model to give you insight. And the bigger the neural network and the more data you can push through them, the more accuracy you can get. Google, OpenAI, they're running machine learning models with over 5 billion parameters now. And this accuracy can apply to every industry and all of their specific use cases. So if you think about it, with such a big breakthrough, what becomes really important is the data. And a company's strategy around getting data becomes a key core strategy of every company. First, get your data out of your silos. Figure out where outside your company you can get useful data. In fact, something really interesting that we've seen is, for instance, in the area of recruiting, we have this sort of machine learning jobs API that we, the more data it gets, the more accurate it is. So we went to these companies that actually compete with each other that have all the data, and we said, look, if you pool your data, you're going to have a much more accurate model. And once 2 companies did it, every other company wanted to do it because they'd be at a disadvantage if they only used their model for their own data. So now I'm going to just talk a little bit about a quick run through of all the different ways, the 4 main ways people are using to train their data, depending on the nature of the data. Unsupervised learning is really kind of the ideal way. You just give the system some data, it figures out patterns and discovers things. And the example I like is that I have a neighbor at Stanford that's a physicist, and his son used to be interested in physics, but then got into machine learning. So my physicist neighbor decided he'd see if he could use machine learning to rediscover the periodic table. And he made a program that, in just a few hours, successfully learned how to distinguish between different atoms after analyzing a list of chemical compound names from an online database. Pretty amazing. A lot of Google's success has come from using a technique called supervised learning, where you start with a data set, you have training data or labeled data, you put in an input, you have an output, so you put in an image and it's cat, you put in a Gmail and it's spam, you put in the radiology image and it's got a broken bone or not. Okay, so that would train it with supervised learning. There's transfer learning, where you have a very carefully built model from one domain where you had maybe labeled data, and it turns out you can transfer it over to another domain. And so, for instance, say you have an image recognition model for family photographs, and you could take that model and move it over to study tire treads, and it could predict when you need to change your tire. Okay, or one of the most interesting ones we've seen was language translation, where you could have French to English and use that same model now to go English to German or something. And then last is reinforcement learning, and that's when you have something with a clear outcome. Either you win or lose. Games are the biggest example here. So you build a model on that can generate input and knows how to play this game, and then you train it on this simulator over and over again. And it just gets better and better at winning. because it's always obvious at the end if it won or lost, and you reinforce the winning. Okay, and this is how DeepMind's AlphaGo program beat the world Go champion. So it's really great if you have a model where there's a clear thumbs up or thumbs down that you can just keep feeding back into the system to improve it, and you just run it continuously. Now, when you go to adopt your AI, it could be pretty simple or it can be pretty complicated. The most profound improvements tend to come from the more complicated ones. But it might just be a one-to-one substitution where you had an existing hand-coded algorithm and you just trade it for a neural net. So you're just trading one kind of computer computation for another. And speech recognition was an example of that. That used to be kind of algorithm-based. And then once they switched to neural nets, they got about 60% less errors almost the first try. I mean, that's the amazing thing about AI is the percentage improvements. 40% reduction in energy usage for cooling we found in our data centers. Humans don't generally make such leaps. Now, if you're trying to automate something that a human does, or something that humans could do, but it would be too expensive to have humans do, you can't just drop in a computation and have it, controlled. Like an example might be a call center, where the computer answers the phone and talks to the person, and should it tell the person it's a computer, and should it try and pay attention to where the person's calling from, and what if it can't answer the question? How do you get it to a human to take over? Or say you're on a assembly line and you're trying to detect a faulty part. Well, you detect the faulty part, that's not very hard, but what do you do once you have this faulty part? Or something that you can't have humans out there doing because there's too many of them is preventative maintenance. So you're looking at, I heard about an example the other day, filters in a brewery, Anheuser Brewery, and when it's no longer clear, you want to know to replace it, but you can't have someone looking all the time. So that's a process change. So just summing up, I hope it's clear that taking advantage of AI requires data. Data is the new oil. These leapfrog improvements over classic algorithmic approaches are driven by the data, particularly labeled data. So you want a long-term strategy, short and long-term, around consolidating your data, getting it out of the silos, getting the most relevant data you can, both internally and from others, getting it processed for the kind of learning you want to do. More data is good, labeled data is good. And then compute, computers have been, as I said, limited for so long by what the programmers were able to do, and now you can do these things that we've never, usefully, that the programmers could never get done. So if you need to figure out how it fits into your business processes, that's really kind of your strategic imperative. You want to have a long-term vision of where you're going, like I want to just fully automate my store or my factory, but you can start very small. I'm just going to inspect this one part. The important thing is to just get going, because this AI is, as we all know, is for real. It's revolutionary. It's going to be incredibly impactful for every business that uses it, and we're here to help you. I'm just incredibly proud to bring up Andrew Moore, who is now running Google Cloud AI as he finishes up being Dean of Computer Science at Carnegie Mellon University. Yeah, tell us about yourself and how you got into AI, Andrew.
Sure. So, by the way, I got to say off the bat, thank you for this awesome job. This for me, this is kind of feels like what my whole career has been leading up to. This is like making AI real. It's just so fun.
Yeah, I used to talk to Andrew when he was at CMU, and he's like, it's all about applied AI. It's all about the process.
Yes.
And I didn't realize that we would be so lucky.
It's great. So yeah, I grew up in Britain in the 1980s. For a while, I became a kind of angry young man in that I was not happy with all the frightening politics around nuclear proliferation and so forth. And at about the age of 16, because I was studying early AI and computing, I took the attitude, I want machines to run the world. I don't trust humans anymore. You'll be pleased to know my thoughts have become a little bit more nuanced than that. But that was what really has driven me initially into this area. The question of, given all these instances where there is too much data for a human to process, but you still want to make great decisions from it, what can we computer scientists do to help?
So did you know about AI before you went to college?
Yes, it was mostly a science fiction thing, but I'm sure we all remember the ELIZA program and stuff like that. And yes, I managed to program something to win at tic-tac-toe using reinforcement learning. So take that, DeepMind.
I wrote a distributed tic-tac-toe program, but I didn't use AI. Yeah. But, okay, so if you were 16 years old now, what would be on your mind, do you think?
Well, talking to my kids' friends, and I do a lot of work with K through 12 education, that generation is pretty mad at the state of the world that we've created for them, and they want to do something about it. And I get great pleasure in really helping them see that with technology, they can start to they've got some sort of power. They're not just at the mercy of everyone else. They can do stuff. For example, this is a crazy new project at the National Robotics Engineering Consortium in Pittsburgh. A giant robot, I think it's almost 70 feet tall, which wanders along rivers with huge slabs of concrete, putting together emergency levees in place to deal with flooding. So that's what I think life should be like for the 16-year-olds now. Is if you don't like the way the world is, really start thinking about what you could build. And then it's the job of places like Google to provide the substrate that they can build this stuff on top of.
Yeah, I love that image.
Yes.
And my kid was all into that steam shovel story, but now it's robot building levees. I really like it. MIT recently made this big splash that they're going to have the AI college, I think it is,
yes.
and to span every discipline. Well, and like CMU actually kind of had done that early. What is going on here?
It is this push from students and their parents who realize that this stuff is real and there are skills that they need. We at CMU pushed an AI undergraduate program out starting a year ago. And part of the reason we wanted to specialize in artificial intelligence, I think, is very critical to understand. We see now that there is a skill of building these adaptive, in some cases autonomous systems, where you've actually got to learn about how society works, how businesses and processes work, and be skillful at bringing in the technology to do the automation. So it is a very different job from a computer science undergraduate program. Computer scientists will always be needed, but the question of putting very advanced automation into a business is a different skill. And it's one that I think is actually more broadly applicable to lots of kids from lots of backgrounds.
It's a new kind of design thinking.
Yes, exactly. It's that's a really good way of putting it.
Yeah.
You have to think about the real problem out there, and then the wonderful sort of imagination is figuring out what are the building blocks which are going to let you solve that problem.
But the amazing thing that's like I see going on at MIT is, and I think it's somewhat at CMU, Stanford, wherever, but is they're actually saying every discipline is computer science and AI.
Yes, yes.
It's very disruptive.
Yes.
For the university, for the institute.
It is, but it's also very exciting, and I think that's why I'm so excited about the platform that Google's building here. A good example of a history student at CMU. She took our introductory computer science course. She happens to have a deaf sister. she wanted as her project to do something where she can help her friends learn American Sign Language, and she was able to set up something which tracks their limbs and then does a kind of dance revolution scoring as to whether they're doing a good job or a bad job. And you know what? 5 years ago, many people would have said to that history student, stop, you can't do that. You're not a computer scientist, go away. But now there is, with the right support, there is the ability for folks to be able to mash these things up.
And so what's the advantage of doing all this at Google instead of CMU?
So, I mean, I've loved every aspect of my career, and the really interesting thing that at Carnegie Mellon, Dean of Computer Science, I experienced, shared with many other universities right now, are the heads of large organizations with very significant responsibilities who arrive to talk about, I've seen the amazing things going on in the labs, but I don't quite see how it can help change our business or help us survive or help us reduce the use of fossil fuels by 40%. And that pattern of folks coming to universities asking for this was inspiring, but frustrating for me just as an academic, because I can describe the crazy advanced new research projects which folks can do, but I didn't have the platform to say, right, here's the playbook, here's what we're going to do for you. Let's go through steps 1, 2, 3, 4, 5 on the AI playbook. Whereas your team, the head of product, Rajan Shetty, have set up a shape of an organization where we can actually put structure on all of this stuff.
It's also a sheer numbers thing. I mean, my husband's an academic, and he's worked in industry and academia, and he's like, well, like, you know, at Stanford, I have a handful of grad students, and they only move so fast and get so much done, and we can't really get it into something that the world can use. And then all of a sudden you go to a company and you have hundreds of people, and it's just amazing how much faster you can go. Yeah, so probably so. So how would you characterize the state of the art today for AI? And then I'll talk about the future.
Very good. So one thing which I'm passionate about is the use of machine learning, as Diane just described, is the key thing, which means that AI is now viable, where 15 years ago it was always a little bit out there in the future. The fact that if you've got the systems in place which let you actually gather data, you can build up models which allow your organizations to predict what's next or predict what's wrong. Where I see us going next is there is actually more to AI than that, and I'm really critically interested in what you do with the predictions from the machine learning systems we give you. So if you remember, the full field of artificial intelligence is about perceiving the world, deciding what to do, and then acting. And so I think you're going to see a huge growth in that, what I call the top of the AI stack, in the decision-making systems which are actually tied to what the machine learning system is doing. You usually cannot just sit back and let the machine learning system make all of its decisions. It has to go through your workflows and decision processes. So that's where I'm betting on the next big area of growth.
What about general purpose AI, GAI?
I'm really glad that folks are researching that at the moment, because it may come to something. At the moment,
there are those that say it will come to something.
Yes. At the moment, there is so much that we can do to increase the safety of people on the world and increase the productivity justice using the existing tool sets, which is improving every year. But
Let me just interject and make sure everybody here knows what we're talking about. General purpose AI is when AI can do everything a human can do, only better. And people feel like whoever gets to GAI first maybe has a real edge in the world, but it's questionable whether it's going to happen or when it's going to happen. So that's what Andrew is talking about.
Exactly.
Yeah.
Listen, I'm sure most of you realize this, but AI is currently very, very stupid. It is really good at doing certain things which our brains can't handle, but it is not something which we could trust to do general purpose reasoning involving things like analogies or creative thinking or jumping outside the box. And there's actually formal proofs of why we should not be able to expect that. And so the last thing I would ever do is sit back and wait to see if someone comes up with a general AI before taking action on AI.
Okay, and last but related
Yes.
question. So in the 1900s, 60% of the workforce were farmers.
Yes.
Today, 2% of the workforce is farmers. That was quite a disruption. There are those that are, we all talking about, normal data processing is going to be disrupted by AI. How do you think about the job disruption that's coming?
Actually, I do believe we all have a duty to be thinking about this. And part of Google's use of the AI principles is that when you're introducing a new technology and you get a choice between using it to empower your current workers and make them more productive and enjoy their jobs more versus just replacing them with a box, we very much push towards the former because that's usually where you get the successes. So these kinds of things, I think, you can get non-zero sum benefits in productivity and make people enjoy their jobs more.
Right, I totally agree. Making people do repetitively mindless things that takes them less than a second is not a great use of humans.
Yes.
We need to do the things that are a lot more complex. Thanks a lot.
Thank you, Diane.
Hello, everyone. Welcome to Let's Talk AI. My name is Rajan Sheth, and I'm Director of Product Management for Google Cloud AI. And I'm going to talk to you about how you can apply AI to your own business. AI is something that we believe will be very pervasive across almost every business. And in fact, IDC projects that by 2021, 75% of enterprise applications will use AI. We want to help you along that journey such that you can apply AI to your business in ways that matter to you. So our goal is to make AI simple, fast, and useful for you. Simple because we want to make it so that everyone within your organization is able to use AI. Everyone from the novice all the way through to the expert. Fast so that you can run this fast and keep running it fast on Google Cloud and also deploy it fast almost anywhere. And useful so that it's solving your most critical business problems. We have 3 parts of our product line that help you solve this: our solutions, our building blocks, and our platforms. And I'm going to talk through these 3 to talk about how we can help you solve particular problems, and then how you can extend this to almost everyone within your organization. So to start off, we're really focused on how do we figure out real business problems. And what we're finding is that in each industry, there's a different way that AI can be really useful. And so we're working with companies across many different industries to try to figure out what are those key problems and how can we solve them. We found a couple that are actually common across almost every industry that we've already built some solutions around. So the first is contact center AI. With contact center AI, what we're looking to do is to figure out how do we make the customer service experience better for all users. And we do this by doing 2 things. One is making it simple to answer questions if you are if you're calling in. And then the other part is to make it so that more complex questions can be answered in a more intelligent way by agents. We make it so that when somebody picks up the phone and calls you, they can get their simple questions answered. And we escalate to an agent and give them information about the call as soon as the agent comes in. Another big area is document understanding. So it turns out that over 80% of the information within a typical enterprise is unstructured information. Things like documents or photos or videos. How can we make it so that you can get better understanding out of those documents and make it so that you can use those documents to make decisions? Right now, less than 1% of unstructured data in an enterprise is used to make decisions. So to do this, we've partnered with Iron Mountain. And Iron Mountain is the data custodian for 95% of the Fortune 1000. And we're working to infuse their technologies with our document understanding technologies to make it so that you can solve this key problem for your business. Now, these are just 2 examples of solutions that we're building, and we're going to continue to build many, many more. But beyond that, we want to make it such that your developers are able to build solutions for themselves and use Google's lead in AI to be able to do it. And so what the second thing we're doing is we're creating powerful building blocks. And we call these building blocks because you can mix these together and join these together to solve particular problems. We've started with taking the best of Google's models and providing them to you in ways that you can use them as services. And this is in areas like computer vision, natural language, text-to-speech, speech-to-text, translation, and video, making it such that you can take many of what we've created and be able to apply it to your own business. So for example, let's say you wanted to create your own digital assistant. You could do that by using our speech-to-text technology, being able to understand what somebody is saying, being able to answer a question, and being able to put that back out as speech. Things like that are now possible. But AI is a mass customization problem, and even the models that we build may not be applicable to you. So for example, most businesses don't really care about being able to distinguish a picture between a dog and a cat. However, a manufacturer will absolutely care if they can take a picture of every product coming off the manufacturing line and figure out if it's damaged or not. But the problem that we hit here is that AI is a very, very complex area where there's a severe talent gap. Right now, there are only tens of thousands of people in the world that can build a deep learning model. There are about 2 million data scientists out there, but there are 23 million developers. And so how can we make it such that those 23 million developers can do great things on their own? So to do this, we've created what we call Cloud AutoML. And this is used to take those great models that we have and customize it to your particular problem. So for example, you can give us a data set of images. We will then use AutoML to use machine learning to find the best model for your particular problem and then deploy that automatically for you on Google Cloud. What this does is that it's easy. So even people without machine learning knowledge, any of your developers are going to be able to use this to create sophisticated models. And it's highly accurate. We're finding that the accuracy of these models are well above those that even humans can create. And so this makes it such that we can solve many of your problems and solve them at the quality level that you would expect. Earlier this year, we released AutoML Vision, which is our first area with AutoML, where you can take pictures in and then be able to create a model to recognize those pictures. But we've added to that AutoML Natural Language. And AutoML Natural Language lets you take in text and then makes it such that we can understand and classify text that you put in. And finally, we built AutoML Translation. This makes it such that you can do custom translation that is relevant to your business. All of these things can solve many, many different business problems and can be used by all of the people within your organization. But then how can we take this even further? We talked about how precious a resource the data scientist is, or the ML expert. How can we make it such that you can actually increase what they're doing and give them the best environment to invent what they're going to invent? So to start off, what we've done is we've built a cloud AI platform to make it such that we can make the data scientist's job and the ML engineer's job easier. We have Cloud Machine Learning Engine, where a data scientist can bring in a model to Google Cloud, train that model, and then deploy that model without having to think of the machine architecture underneath. So they can focus on what they do best, which is build the model, and we can focus on deploying that in the right way. Now, for machine learning engineers that want to do more and be able to get at the machine level, we've implemented what we call Kubeflow. Now, Kubeflow is machine learning built on Kubernetes. And this makes it such that in Kubernetes, you're able to have containers that bring in the best of machine learning technology. And then you can flexibly edit that. You can also move these. So you can run this anywhere where Kubernetes exists, in Google Cloud, in another cloud, or on-premise. And so this makes it such that ML is all of a sudden transportable. And the last part is that we make these fast. We offer CPUs and GPUs, and we also offer what we call cloud TPUs, our tensor processing units. And what this does is it takes certain types of workloads, things like image recognition, things like language recognition, and makes them much, much faster for training. And these are things that are getting better and better and better by the year. We actually just introduced our third generation version of TPUs very recently. But we want to make your developer 10x more productive and your data scientist 10x more productive, such that you can use that precious resource in a much better way. The insight, though, that we're finding is that much of the work that data scientists do actually go to waste. The vast majority of models actually never make it to production. And the reason that happens is that, one, there's no great way for them to experiment and find the best model. Two, once they find a model, it's very hard to actually bring it into production. And third, it's then hard to actually then integrate that model into the workflow of how your organization does business, into your applications, into your users' workflows. So in order to really make this a reality, we need to recognize that AI is a team sport. The machine learning code is actually a very small part of this, and there are many other people involved that create the end-to-end machine learning workflow. There's everything from the data engineer all the way through to the production engineer, all the way through to the application developer, and all the way through to the end user. How can we make it such that these groups can work together more productively and more collaboratively, such that you can leverage that work of your data scientists? So to help solve this, we're introducing what we call Kubeflow pipelines. And as the name implies, this makes it such that all of those individuals and those teams can work together in a pipeline to make the whole process fit together. So a data engineer can go and get the data from the right place and build a module to do that. Another data engineer might be able to build something to transform that data. The data scientist can build a model that's part of the pipeline. And then an application developer can convert that into an API that they can use for their particular application. In addition to that, we've tried to make this composable so that, let's say the data scientist has a better idea for a model, they can swap that out. So let me show you what this might look like in practice. So the way things are done right now is that, let's say you have an ML expert that wants to create a recommendation engine for 3 lines of business of yours. What they're going to do is recreate that work for every single one of these businesses and recreate it from scratch. Now with pipelines, what they can do is encapsulate that model as a pipeline that has fixed inputs and outputs. And then the other work can be done around it. So for example, if one division is doing demand forecasting for toys, they may have different data than another division that's doing demand forecasting for clothes. And so all of those divisions can then use the same pipeline and put their own data around it. Now then the other part of this is that, let's say you then want to actually bring this out to multiple businesses. It becomes very easy to do. Because that ML expert will just need to do their work once, they can use the same model and the same pipeline for all of these business units that are using this. To make it even better, suppose that machine learning engineer has a better idea of a better model to be able to solve this. They can simply swap this in, and everything around it stays constant. And what that does is it makes everything better without having to change everything else that everyone else is doing. And so this makes it so that you can improve the productivity of your data scientists, and you can improve the productivity of the rest of your team and coordinate them and orchestrate them all together. Now, all of this is great, but what about the content behind this? And if you think about why content is so important, think about the BlackBerry and how we used to use the BlackBerry, say 10 years ago. Almost all of us had BlackBerries, and we used it for email and calendar and things like that. But what made the smartphone really take off is that you had millions upon millions of developers building all kinds of great things for the smartphone that ran in a consistent way, so we can now use our smartphone for many, many different things. We can use it for tracking our runs. We can use it for tuning a guitar. We can use it for almost everything that we do. The same thing needs to take place in AI. Right now we have a fixed set of applications, but we will need to make it an ecosystem. We need to make it so that you have access to millions of ideas out there. And to do this, we're introducing what we call the AI Hub. The AI Hub is your one-stop shop to be able to bring in content and share it amongst data scientists and developers within your company, and to also bring in outside content that you can use as a starting point, so you don't have to start with a blinking cursor. What we're going to do is be able to populate that with a lot of the best content that we have. We have what's called TensorFlow Hub, where we brought some of the best TensorFlow models that we use internally, and we bring this to be available to you in the hub. We have Kaggle, which is the largest community of data scientists, where we have tens of thousands of data sets, and we're bringing these into the hub and making it available for you. We have all of the models with our building blocks that we talked about earlier. These are also now available, along with many other things to make the job of machine learning a lot easier. So to show you how this works, take the example that we had before, where we had a recommendation example. Let's say that data scientists wanted to publish that. All they would need to do is go to the hub here, hit publish, enter in information about their model, give it a description and upload that model, and tell us a little bit about it. And what they can then do is publish this to their corporation and make it so that anyone within their organization has access to this. So then somebody can go and find that, look at it, understand the information behind it, and then start to use it on their own. This makes it such that they don't have to start from scratch. They can start from work somebody else within their organization has done. And then, as I mentioned, we're going to pre-populate this. So for example, we have great TensorFlow models that do all kinds of interesting things, just like this one, which recognizes handwritten characters. We're putting that into this hub such that you can take this, use it, and integrate that into your pipelines as well. This makes it such that you have a one-stop shop by which you can collaborate with others within your organization and use our own content to be able to advance your machine learning goals. So as you can see, the combination of Kubeflow of pipelines and AI Hub can start to make your team even more productive and leverage your precious data resources with your data scientists and your machine learning engineers. But this is just the beginning. Many of you remember this. This is, of course, the Mosaic browser, and in 1994, it was the first time that the average person saw the internet. Many of us who used it remember our aha moment with the internet. For me, it was live sports scores, where all of a sudden I could see how the internet could affect my average life. What's important about this is where AI is today. We're just at the beginning of every person seeing how AI can affect them. And just like the internet over the last 20 years, we believe that AI will become the foundation of computing over the course of the next 20 years. We're looking forward to working with you to help make this a reality and help make it effective for your business. Thank you very much for joining, and please enjoy the rest of the conference. And we're looking forward to working with you more.